So we have to make quick summary of thermal property of matter. It is like one shot of thermal property of matter where we are covering most of the formula and their basic understanding.
बरिंदर को कॉल कीजिए
Hmm?
बरिंदर को मतलब बुलाइए
नहीं, वरिंदर को बुलाएंगे जब एक बार ये सारा हो जाएगा क्वेश्चन करने टाइम। ठीक है।
अच्छा हाँ ओके
तो
ओके हाँ
दिस इज वन शॉट ऑफ थर्मल प्रॉपर्टीज मैटर. Now because you all three of you made notes out of this chapter, now it will be easy for you to understand this. Got it? That's why we can make one shot. Probably I'll try to finish it in next half an hour, like less than half an hour. So you know one thing, you have temperature, degree of hotness or coldness, right? And there are different unit. It could be Kelvin, it could be degree Celsius, it could be Fahrenheit. Not degree Kelvin, only Kelvin. Okay. One thing. Heat. Heat is one form of energy which flow from hot body to cold body always. Reversible is not possible, and it is always because of the temperature difference. Okay. You usually measure in the form of the calorie heat, and 1 calorie is equal to 4.18 joule to be precise. Okay. Then heat are present in the different form. There are continuous motion of particle, could be in the translation motion, vibration motion, or rotational motion. Right? That's why if you calculate the total kinetic energy of all the particle, it is the kinetic energy because of the translation motion. Due to vibrational motion, V means vibrational motion, and R rotational motion. ठीक? Next, while we were dealing with the temperature, so temperature, you can convert degree Celsius into Fahrenheit. It will be 9 by 5 degree Celsius plus 32. And in Kelvin, given degree Celsius plus 273.15. These are the two popular formula where you convert one unit of temperature into the other one. Okay. Then you need to know the freezing point of water and boiling point. Though this is very easy. For water, freezing point is and boiling point is. Anvita, what is the freezing point of water? Anvita, Pratigya,
सर अब क्या
Chandana.
0 डिग्री
Freezing point of water,
ओह 0
0 degree Celsius. Pratigya, boiling point of water,
100 डिग्री सेल्सियस
100 degree Celsius. So sometime you need to compare between different type of parameters. So one of the famous formula is in degree Celsius minus, uh, you can take freezing point divide by boiling point minus freezing point. And not only degree Celsius, any parameter. You can write T temperature. Temperature of any parameter, it will be remain constant. Now depend ki what is given. Based on the given situation, you can write different formula, but this is the formula. Example, if you take in degree Celsius, 0 degree Celsius is freezing point, boiling point is 100 minus 0. In Fahrenheit, freezing point of water is 32. Boiling point of water is 212 minus 32. In Kelvin, freezing point of water is 273.15 divided by Boiling point is 373 minus 273. Actually, we also use 1.15, but we are ignoring because it's easy to do calculation. So these are the three versions most commonly we use. Okay. Even you can use mercury thermometer in case of mercury because this is one of the PYQ question. In case of mercury thermometer, it can measure from minus 30 degrees Celsius to 357 degrees Celsius highest. Okay. You know, many times we have solved this, so I would like to ask you, ki, Chandana, what is ideal gas equation?
PV is equal to N.
PV is equal to nRT. Pratigya, what is Boyle's law?
Pressure inversely proportional to volume.
Pressure is inversely proportional to volume if number of mole and temperature is constant.
Constant.
And that's why if you draw graph of P and V, it will be parabola. Anvita, what is Charles' law?
The pressure is constant and
Hmm.
volume is like proportional to temperature.
Volume is directly proportional to temperature. Chandana, what is Gay-Lussac law?
Volume remains constant, sir. Pressure is directly proportional to temperature.
So N and V is constant and graph will be straight line for the pressure and temperature. Okay. Next, Pratigya, what is absolutely zero temperature?
मतलब -273 Kelvin, 0 degree Celsius.
Zero Kelvin. At absolutely zero temperature,
-273.
volume will be zero and pressure
0,
will be zero.
0.
Okay. So, Anvita, what is linear expansion?
So like when we heat something like the length increases.
Uh,
Uh,
and change in length depend upon the original length,
L delta T. Yeah, this one.
delta T, and change in temperature as well as material.
Yeah.
Pratigya, what is area or superficial expansion?
Del V equal to V alpha L alpha B del T.
A alpha B delta T. Chandana, what is
V
the
alpha B.
what? Yeah,
Alpha A.
alpha A. Yeah, so it's your choice which symbol you want to use. So if you want to use alpha A, that is fine. Chandana, what is volumetric expansion or cubical expansion?
Change in volume depends upon the original volume and temperature difference.
And also nature of material. That alpha A, V, L, all these are telling the nature of material. Anvita, what is the relation of alpha V with alpha L? And Pratigya, alpha A with alpha L.
A वाला 2 होगा, अब वॉल्यूम वाला 3 होगा.
Hmm. Three time because volume directly depend upon the L cube. Okay. Even density formula remains same. Change in density by original density is equal to final density minus initial density divided by the initial density. Okay, so change in the density will be equal to alpha V delta T original density. Same way, how you take volume, same way density is considered. Chandana, what will be the thermal strain?
Sir, what?
Thermal strain. According to this formula, delta L by L will be equal to alpha L delta T. So if delta L by L alpha L delta T is there, same thing is also known as thermal strain. And what is the formula of Young modulus, Anvita? So if you are taking strain, strain will be equal to stress upon Y, or if stress is asked, it will be Y into strain. Okay. And what is strain value? Y alpha L delta T. Okay. And one time question was asked, what is the value of force? So, Pratigya, what is the formula of stress? So, these are all things depend upon what is given in the question. Okay. So, you have three different words. Remember one thing, keep telling me answer. I can't wait during the one shot because we have to finish it fast. Okay. So I can't wait. Okay, what will be your answer? So keep telling very, very fast. So Channa, what is heat capacity?
Sir, amount of heat required to rise temperature by 1 degree Celsius.
Yes, so change in heat for given change in temperature for 1 degree Celsius, 14.5 to 15.5. And with a specific heat capacity,
तो आपने मुझसे पूछा
हाँ,
हाँ okay so like amount of heat required to raise temperature for like 1 unit of mass I think.
Pratigya, what is molar heat capacity?
We require for a 1 mole of water.
For 1 mole. Yeah. So by the way, if you consider which material have highest specific heat capacity, so highest specific heat capacity is present in water. That's why water is very good material that resists any kind of change, because you need maximum amount of heat to increase temperature by 1 degree Celsius. That's the reason why water is also used as coolant, because it maintains situation for long time. Its value is 4180 joule per kg per degree Celsius. That is the specific heat capacity for water, which is the highest amount. Obviously, this question can be asked, why water is used as coolant, not coolest, coolant, because it has maximum specific heat capacity, so it resists any kind of change. Chandana, what is the water equivalent?
So mass of water is almost equal to the given body.
So it is the water that has the same specific heat capacity of the body. Yes. So it is the water have same specific heat capacity. He- Heat capacity, specific heat capacity. Then Pratigya, what is the calorimeter principle?
Hot body always lose heat and cold body
Hmm.
always gain heat. इक्वल होता है.
Heat loss is equal to heat gain. So if here mass is m1 c1 delta t 1, it will be equal to m2 c2 delta t2. That is the main principle of the calorimeter. The heat lost by the hot body will be equal amount of the heat gained by the another body. Okay. And Anvita, what is the triple point of water?
So like all the phases are like together present, and they're like in equilibrium, I think.
So water is present in solid, liquid, and gas at the same temperature. That is 0 degrees Celsius. Okay. Chandana, what is latent heat formula?
So Q is equal to ml.
So ml. Okay, and L value depend whether it is the heat of latent heat for the vaporization or for the freezing process. Pratigya, what are the different method of heat transfer? Conduction, convection, and हाँ प्रतिज्ञा क्या हो गया नेटवर्क काम नहीं कर रहा अनम्यूट नहीं हो रहा है सुनाई तो दे रहा है ना ठीक है तो कोई बात नहीं बस अभी तो खत्म ही होने वाला है तो तब तक कुछ ट्राई करो ठीक है so there are three methods conduction convection and radiation in conduction it mostly occur in solid and you have vibration what happen Anvita in case of convection displacement of the particle
Yes.
flow of the particle like in liquid or gas Chandana what happened in radiation transfer of
The
material
transfer
without
of heat takes place without any medium.
yes so we have in conduction very important concept of the thermal conductivity it means if you have two body A
अभी हो
and
रहा है.
हाँ आवाज आ रहा है A and B and there is a road that connect A and B this road have length L area A okay so what is the amount rate of heat transfer in this case what is the amount of heat transfer through the road that amount of heat transfer is known as H also known as heat current okay so this H value will be what is the change in the heat in given unit time which is directly depend upon the area change in temperature and inversely proportional to length it means more length less heat transfer like slowly it will transfer more area quickly it will transfer same way depend upon the temperature Anvita how you compare Ohm's law in this case with the heat transfer So how
But I
V
don't
is
want
equal to
to.
IR in case of Ohm's law? Same way, here we have delta T, change in temperature is responsible for the heat current. So through this, you will come to know that K H is equal to delta T by R. Correct? Delta T is same. So R value will be equal to L by K. Okay, so this prove that here R is the thermal resistance and this R value is equal to L by Ka. Okay, R value is equal to L by K. Chandana, what happen in case of series combination of thermal conductivity? K is thermal conductivity. If you connect two rods together, so what will be the thermal conductivity?
So we have to add the resistances.
Yes, resistance will be added in the series combination. And what will remain same in this situation?
Correct.
Area will be same. Area will be same. And if you calculate the thermal conductivity equivalent, it will be 2 K1 K2 divided by K1 plus K2. Okay? And Pratigya, what will happen in case of parallel combination?
Divide होगा
Hmm. So
K1 by
resistance
2.
will be the inverse 1 by R1 plus 1 by R2 when you calculate all the thing. So what will be the combination? K equivalent will be equal to K1 plus K2 divided by 2. This is the parallel combination in case of thermal conductivity. K is thermal conductivity. Or so hello. ज्वाइन नहीं नहीं पता चल रहा है मुझे हो गई भेज दिया मुझे नहीं हो गई हम्म हाँ पीडीएफ ग्रुप में भेज दो हाँ सो parallel combination is K1 plus K2 divided by 2. So this is all about the conduction. Second is convection. And convection, Pratigya, what is convection? Flow
Liquid
of,
और gas fluid flow.
in case of liquid and gas, you have flow of water. Example, in case of liquid. Remember, whenever liquid or gas move, it always move from the high pressure to low pressure. Always blow from the high pressure to low pressure. Okay. And last, radiation. Anvita, what happened in case of heat transfer through radiation? Without medium,
Without
it will be transferred.
yeah.
How sunlight is transferred. Whatever the color we see of any object, it is due to Chandana,
Electromagnetic.
radiation emitted by the material will decide the color of the material. Okay. So, Pratigya, what is black body?
Absorb all type of radiation.
Yes, a body that absorbs all type of radiation is known as black body. So, Anvita, what is emissivity? Emissivity
So
is the,
suppose
what
it
is the emissive power of the body divided by emissive power of the perfect black body. Emissive power of body divided by emissive power of perfect black body. Okay, so that is the emissivity, opposite to the absorption power of the body. Next is very important. So I'll take slightly more time because you asked me, sir, you are not able to explain, like understand it properly. Anvita, what is Stephen Boltzmann law? It says that the total energy present in unit time per unit area, landing on a given area in given time, this total energy E will directly proportional to the temperature raised to power 4.
yes,
Okay, and there is a proportionality constant lambda. This is Stephen Boltzmann constant, and this lambda value is equal to 5.67 into 10 raised to power minus 8 watt per meter square per Kelvin minus 4. Okay, this is for the perfect black body, but no body is perfect black body. So in that case, total energy per unit time per unit area, you will consider emissivity. This is for the imperfect black body. First one was for the perfect black body, and this is for the imperfect black body because there is always emissivity from imperfect black body because black body never emit anything. It will absorb each and every stuff. Okay? Next is Wien displacement law. Pratigya, what is Wien displacement law?
frequency डायरेक्ट टेम्परेचर होता है और वेवलेंथ
It says
इनवर्सली
that
प्रोपोर्शनल
wavelength will inversely proportional to the temperature. Wavelength emitted by in the form of radiation inversely depend upon the temperature. So wavelength and time value remain constant. Okay? And this constant value is 2.9 into 10 raised to power minus 3 meter Kelvin. Sandana, what is Newton law of cooling?
So rate of cooling of body is directly proportional to temperature difference.
Yes, rate of uh, cooling of the body will directly depend upon the temperature difference. Usually this temperature difference is small. Usually this temperature difference is small. And when there is a cooling, then heat will be lost. So rate of heat loss, Anvita, is equal to minus dq by
dt is
dt.
equals to k
Heat loss per unit time is
is
equal
equal
to
to
K
t
constant
minus t naught.
T minus T naught.
Yeah.
This is Y minus because heat is lost. If heat is gained, then it is plus sign. Okay. One more thing. This T naught is the surrounding temperature. Sometimes two different temperature will be given in the form of T. Then you have to take T1 plus T2 by 2. Average temperature. Two different temperature will be given other than surrounding. So you have to take average temperature. Okay. So we took exactly 29 minutes to revise this full chapter. Tell me guys, was it really difficult?
No, sir.
No,
So this was the one shot of the thermal property of matter. Now we can solve question from this. Brinder, are you there? Brinder.
Yes, sir.
Uh, just give me 1 minute. Sharing. This is the recent question. Then we'll do other question like other than PYQ also. Let's start with PYQ first. Two roads, one made up of copper, another made up of steel. Length is same, even area of cross section is same. Thermal conductivity of copper is this and steel is this. The free end of the copper and steel are held at 100 degrees Celsius and between 100 degrees Celsius and 0 degrees Celsius. What is the temperature at junction? What is the temperature at the junction? So, how to solve this kind of question? Length and area is same, right? And when length area is same, uh, there are two extreme side. Yeah. So this was the question number 16. Okay. What is given? Example, you have this road. One side you have 100 degrees Celsius temperature. Another side you have 0 degrees Celsius temperature. Okay. Then you have copper rod and another side you have steel rod. Okay. You have to find what is the temperature in the common. What is this temperature T? Both have same length and same area. Even their thermal conductivity of copper is given and thermal conductivity of steel is also given. You have to calculate common temperature. Okay. You know thermal current or rate of heat transfer or thermal current is the same thing. In both situation will be same. You have exactly same area, same length, then their um, thermal current will be also same. Okay? Thermal current will also be same, and you can read this question again. Why? Look at this. Two rod made up of copper, another steel have same length, same area joined together. Thermal conductivity of these are given. Free end of copper and steel are held at this and this temperature to extreme. You have to find temperature at the junction. And what actually you are doing is you are calculating this temperature. T. Okay. In this case, heat current will be same because there is the same length and same area. Got it? Same length and same area. So what to do in this case? You have to calculate what is the heat transfer in first case. You know formula is K A delta T by length. Always write formula while you are solving question. Always. Now put values. Example, K of copper is given. I will write K of copper. Area is A. Length is L. What is the change in temperature? One side is it is 100. Another side is T. For H2, same formula. Ka delta T by L. K of the steel is given. Area is same. initial temperature is T, and another side you have 0 degrees Celsius by length. Correct? Both value will be same. So you have to keep both together. K copper area 100 minus T divided by L. So L will be cancelled. A will be cancelled. You have to calculate what is this? What is the K steel and K copper value? 385 and 50. Copper is 385 and steel is 50. Right? Copper is 385 na? And steel is 50. 50 T minus 0 is equal to 385 100 minus T. Correct? So it will be 50T is equal to 385 100 minus 385T. You can take T one side 50T plus 385. T is equal to 385 100. Then you will get the value. Uh, this will be 435. T is equal to 385 100. So 435 will go down, then numerator, and you will get answer. Tell me, do you have any doubt?
No, sir.
You, you can ask one question. Ki, sir, we understand all the calculation we can do. We have to understand what is given. In this situation, why current is same in both the road H1 and H2? Because in case of series combination, you know in electric circuit current is same here. Heat current will be same in case of series combination. Understood? Any doubt?
No, sir.
No, sir.
In series combination, how current is same here, heat current will be same in the series combination. If heat current is same, you have to put formula. Area length is same, you have to find the common temperature. Just put value and then get answer. Right? This question you will feel ki very long, but actually this is one of the shortest question if you understand what is given in this. Like a deep rectangular pond have surface area A containing water of density rho, specific heat capacity S, located in the region outside temperature is this. Thickness of the frozen ice layer in this pond at a certain instant is X thickness of the layer. Taking thermal conductivity of ice is K and latent heat of fusion is L. You have to calculate rate of increase in the thickness of ice layer. It means dx. How thickness is changing at this instant would be. Okay. Initial thickness was x. Now thickness is changing. You have to calculate what is rate of thickness na dx by dt. What is the length changing with the time? Rate. Rate always meaning is with respect to time. Got it? K value is given. Density is given, specific heat capacity is given, how to calculate in this case. Okay. So, you know, if we have to calculate this question, like we have to solve this question, you have to understand one thing. Let me make it bigger. 17th question. Question is given ki thickness, initial thickness was x, ice thickness. Now it is increasing dx with respect to time dt. How much it is increasing, you have to calculate. How to do this? First, understand rate of change in heat with change in time is equal to K A delta T by length, right? Any doubt?
No,
Here you have word latent heat of fusion. What is the heat of fusion? When liquid convert into solid, right? Latent heat of fusion. Liquid convert into the solid. So, do you know कि this latent heat of fusion will be equal to mass into constant, latent heat constant. Make sense? That is the Q value. Any doubt?
No, sir.
Yeah. So, delta Q value will be M into L. Delta T will be same. K will be same. Area will be same. Then temperature difference 26 to 0 divided by length is X because original length of the ice layer was X. Got it? Now, density is also given in this question. How to correlate with the density? You know, density is equal to mass by volume. So, what will be the mass value? Density into volume, correct? And what is volume? Area into dx. Because volume is changing, area is fixed. Overall volume is changing. So, area into dx will be equal to the volume, correct? So, instead of m, you can write rho A dx L by delta T is equal to K A 26 by X. A cancel. What will be the value of dx by dt is equal to K 26 by rho L and X. Tell me, do you have any doubt? I understand. For very first time, you take time to pick up the topic. Let me revise this question again and then correlate. Here, you have a deep rectangular pond of area A. So, A is given, area is given. Okay. Density of water is also given. Okay. Specific heat capacity S is given. Located where outside temperature is this. Outside temperature is minus 26 degrees Celsius. Thickness of the frozen ice layer. You know, ice is present at 0 degrees Celsius, right? Thickness of the frozen layer is x. So length is equal to thickness is equal to x. Taking thermal conductivity K and specific latent heat of fusion is L. Rate of dx by dt you have to calculate, and these are the options given for you. Okay. So according to this question, what will you do? Delta Q by delta T, K A delta T temperature by length. So this heat is equal to ml, and mass you can convert into the density and volume. K fix, area will be cancelled out. Change in temperature is like 0 and minus 26 degrees Celsius, and length value is equal to x. Tell me. Now you have doubts. This delta Q is equal to M into L, and M value is equal to density into volume, or is equal to density area into dx. So mass is given, L remains same, delta T remains same. All other value you can put. Now look easy. Yes or no?
Yes.
Next question. First, both of, like, not both, all four of you tell me, is it series combination or parallel combination? Anvita, series or parallel?
Parallel.
Parallel. This is parallel combination. In case of series, it would have been like one slab and second slab. Both will be joined together, right? This is series combination, like K1, K2. These are series. But one above other is parallel combination. So if you want to calculate here thermal conductivity, Chandana, what will be the answer?
So option D, K1 plus K2 divided by 2.
Option. Correct. In parallel combination formula is this done. Why? Because in parallel combination, resistance will be 1 by R1 plus 1 by R2. Correct. And thermal resistance formula is L by Ka. And now you look at this, this parallel combination. This was the direct formula they asked. So you can mark this is extremely important because they asked direct question. Right? So it is PYQ. Right? Direct question. Anybody have doubt in this? Now look easy. Now you have to solve the question. I gave you some idea. Two end of the metal rod are maintained these two temperatures. T1, T2 temperature difference is given. The rate of heat flow is this. So dq by dt delta, okay, delta q by delta t value is given 4. If the end were maintained at temperature 200 to 210, what will be the rate flow? In first case, delta T value is 10 degrees Celsius. If in next case, this is again 10 degrees Celsius, tell what will be the heat flow. All of you have to answer this question. Chandana, this is given in the question. All of you have to answer. Initially,
C.
temperature was A or C?
E.
What is that?
Option C, sir. For the
Option C. Yes, because you know delta Q by delta T is equal to Ka delta T by L. So this heat current delta Q by delta T heat current directly proportional to the change in temperature. Correct? In this case, change in temperature is 10 degrees Celsius. Even if you are making it 200 to 210, still difference is 10 degrees Celsius. And it depend only on difference. So answer will be same. If difference is same, answer is also same. Anvita, you have to solve this question. Two metal rod, 1 and 2. Length is same. So L1 is equal to L2. Same temperature difference. Delta T1 is equal to delta T2. Between their rod, their thermal conductivity are K1 and K2, and area is A1 and A2. If the rate of heat conduction in one is 4 times of 2, so rate of heat conduction in one is 4 times of heat conduction of 2. You have to calculate their relation. Solve it. All four of you solve it and then tell me answer. Anvita, you have to tell me first.
So is it B?
Yes, it will be B. How? H1 value will be K1, A1, delta T by L. Second, K2, 4 times. K2, A2, delta T by L. Because both temperature is same. So delta T cancel. Length cancel. K1, A1 will be 4 times of K2, A2. Done. Was it easy? Everybody.
yes,
So, Chandana, a slab of stone of area is this A. Thickness is this. Exposed to the lower surface of steam, one temperature is this. Block of ice at temperature this at rest on the upper surface of the slab. So this is the slab. Lower surface 100, upper surface 0. Right? Area is this and thickness is this. In 1 hour, time given is 1 hour. 4.8 kg of ice is melted. Mass of ice is also given 4.8 kg. Thermal conductivity you have to calculate. And latent heat of fusion of ice is 3.36 into 10 raised to power 5. All of you calculate and tell me the answer. Chandana, you have to tell me first.
okay.
And in the end of the session, you all of you have to send me PDF of the solved question during the class.
So can I use the calculator?
Yeah, make it fast. Use calculator.
Sir, option A.
Option A. Everybody got the same answer? A answer is correct.
Can you tell?
Yeah. So let me write what is given. Question number 21 it was, right? In a slab, you had a slab. On the lower side, temperature was 100 degrees Celsius. On the upper side, you had 0 degrees Celsius. So delta T in this case, you can say change in temperature is 100 degree, right? Then area of this slab is 0.36 meter square. Okay, area is given. Thickness, length is 0.1 meter. Correct. Mass of the ice. What is the mass of the ice given? 4.8 kg. Na?
Yes, sir.
And what is the latent heat of fusion? 3.36 into 10 raised to power 5. Correct. Time, this ice will melt for 1 hour. So you can write 60 minutes and 60 seconds. Time is also given. What you have to calculate K value, thermal conductivity. You know rate of heat transfer delta Q by delta T is equal to K A delta T by length. Okay. This is the formula. Always first write formula before solving questions. Delta T is given. This is given. Area given. Yes. Length given. Yes. Time given. Yes. Time is also given. What is this delta Q value? You know it is equal to ml. Correct. So m L delta T is equal to K A delta T by L. Everything is given. Mass given, L given, T given, everything is given except K. So simply put K value is equal to M L small l divided by change in time, area, and change in temperature. Put the value, you will get the answer. What is this value? 4.8. Capital L value 3.36 into 10 raised to power 5. What is the length value? 0.1 divided by time 60 minutes, 60 seconds, 3600 seconds. Area 0.36. Change in temperature 100. You can get answer right. Was it direct question formula based? Got it? Yes or no?
Yes.
Slender road, thermal contact. Yes. Pratigya, am I audible?
Yes, sir.
Yes. Solve question number 22. Remember, I will check notes of everybody after the class. You have to send me in the group to solve every single question. It's okay if you are not able to do, you tried, but were not able to reach to the final answer. It's okay. But so,
मैं बता दी.
हाँ, cylindrical metallic rod है in thermal contact with the two reservoir of heat of the two end. Amount of heat within Q value is given, time value is given. Metallic rod is melted. Okay, melt पिघल जाना, melt होना. Material is formed into a rod. So metallic rod is converted into rod have half radius of the original radius. So new radius is half of the original radius. What will be the amount of heat conducted by the new rod when placed in the thermal contact? It simply is कि when you had old rod, its radius was r and amount of heat transfer was q. If you reduce the radius by half r by 2, what will be the new value of the heat transfer? Got it? That's all. Solve it. This is the same method you use even in the current electricity while you calculate resistance of a wire. If you change the length of the wire and area of the wire, what will be the new resistance? This kind of question you solve from the current electricity chapter also. Almost same kind of question.
Sir, option C.
Option C. Try it again. Any other answer?
Option D.
Try once again.
Sir, option
बस
E,
दो
please.
try once again. Now
Option
only
B.
one option is left. I want to see like how. Hmm. Let me explain. Pratigya, you got answer?
कर रही हूँ.
Main concept in this question is question number 22 is that when you melt a wire or rod, whenever you melt a rod or wire, doesn't matter, volume always remain constant. Correct? Area and length will change, but volume will constant. Example, initially, radius of the wire was r. So you know area of the rod will be equal to pi r square. New area will be equal to new radius is r by 2. Question mentioned this. कि new radius of the rod is half of the original radius. It means new area will be 4 times of the original area. Correct? This is the area. But you know when area is changing, length will also change. But volume remains constant. When area changes, length will also change, but volume remains constant. It means volume before melting and volume after melting will be constant. Correct? So volume before melting was area A and length L, and new volume area A dash and length L dash. Right? So original area A, length L, new area A by 4, length you have to calculate. Area cancel. What will be the new length? L dash 4 time of L. Now you got everything. Now you can apply everything. So initial heat per unit time was K A delta T by L. Correct? This is the original one. New heat per unit time is K is same because same road. Area is A by 4. Delta T same and length is 4 time of the original length. Correct? Ka delta T by L is equal to Q. Tell me, do you have any doubt? You just need one concept from current electricity as well. Whenever you change the shape of the road or wire or anything, volume always remain constant. In this case, when you are changing radius, area will change as well, length will change. Yes or no? This is direct question. But in the for you, what is the answer?
C.
Very difficult question it is. कैसे सोल्व किया इतना टफ क्वेश्चन बरिंदर? बरिंदर
Yes, sir.
कैसे सोल्व किया इतना टफ क्वेश्चन? तुमने तो पूरा क्वेश्चन भी नहीं पढ़ा था. Like
So
how did
formula
you
पे
solve?
पूछा था.
Exactly. This is the level of need. Like that's what I'm saying. He in test if you get difficult question, few difficult questions, don't solve it because most of people will not be able to solve it. But you cannot leave easy question. See, length L, area A, temperature T1, T2, what will be dq by dt value? To the row. Direct formula based question. You can ask her, this time they will not ask. We never know, correct? So most of questions are like this. Anvita, 28th question.
The C.
The natural convention. Naturally, this gravitational field is required for the heat transfer by the natural convention because flow of gas fluid is how this thing actually occurred due to the temperature difference in vertical direction. Right? So ups down movement due to the gravity is actually natural convention because flow convention means flow naturally. Okay. Now this question look like repetition. A cylindrical rod having temperature T1, T2, rate of flow of heat is Q1. If all the linear dimensions are double and temperature is constant, what will be the Q2 value? Linear dimension double. What will be the Q2 value? dq by dt is equal to Ka delta T by L. So everything is same. Delta T same, K same. But linear dimension, area and length is changing, double. What will be the value? In this case, area, linear dimension is changing means let's take like
Q
you
one
can
to
take
be
cube or you can take rectangle. So L square, new length will be 2L square. So it means 4. Area become 4 times. New length will be double of the original because everything is double. So area is 4 times, length is 2 times. What will be the new charge? Area 4 times and length 2 times. 2 times. Yes or no? Yes or no? Or should I explain this?
सर डिवाइड नहीं होएगा
डिवाइड ही तो किया है 4 डिवाइड बाई 2 all linear dimension are double. All linear dimension. Question number 27. When we are saying ki all linear dimension are double, it means length, new length will be double. New area. What is the cylinder area? 2 pi RL, correct? So radius will be doubled, length will be doubled. So can we say area, new area will be 4 times of the original area, correct? Area become 4 times, length become 2 times. You have to calculate new dq by dt. So K same, area become 4 times, length become 2 times, correct? Yes or no? Yes or no?
Yes.
Yes.
2 road K1, K2, area A1, A2, length are equal, temperature T1, T2, what will be the rate of flow will be equal if H1, H2 is also equal. What should be the answer? This is a repetition. Who will tell? Pratigya. Pratigya.
कौन सा नंबर था 26
हाँ,
आंसर 2 होगा
exactly. This is the repetition of question. Second, 2. Why? Because if rate is constant, it means A1 delta T by length is equal to K2 A2. Temperature difference is same and length is same. This is given. Length is equal. Temperature difference is same. And rate of flow of heat is also same. Equal. You have to calculate this. So, you know, length cancel out. Temperature cancel out. A1 A1. Anybody have doubt? Just imagine all the question in this topic asked only from this. So, these two questions you have to solve and you have to send me. Okay? Because everything else we have solved, you have to solve these two questions. Send me. If you have doubt, you can ask me. Because probably you will find it easy. A compound slab consists of two different materials, have same thickness and conductivity K1, K2 value is 2K1. Equivalent thermal conductivity of this slab. What should be the answer? बता ही दो. Who will tell? Sandana. Sandana. Just tell me, Sandana, in this compound slab, there are two different materials but same thickness and conductivity is different. So if they have same thickness, can we say they are in series? And what is the formula for series? Yes or no? What should be the answer? Am I audible? Am I audible?
Yes.
Yes.
Huh. So what should be the answer?
आंसर
सर वो क्लास में नहीं है.
अच्छा, संजना क्लास में नहीं है. So what should be the answer?
B.
2. K1 is K. K2 is 2. K1 plus K2. Yes or no? Right? Just direct formula, series formula directly. Last question, Anvita, 24th. Will conduct maximum heat. 24th. Which road conduct maximum heat? Formula is this. If everything else is same, so this heat transfer will directly depend upon the area inversely proportional to length. Area depend upon R square inversely proportional to length. Directly depend upon R square inversely depend upon the length. Now you have to try all the options. In first case, it will be R naught square by L. Second case, R naught का double 4 R naught square by L. Third case, R naught square by 2L. And fourth case, 4 R naught square by 2L. Anvita, क्या आंसर होना चाहिए? What should be the answer?
तो मेरे को समझ नहीं आया.
Question is, कि you have circular road, radius is R, length is L. They are made up of same material, means K value is same. Maintain at same temperature, delta T is also same. Which one will conduct most heat? If in every case K is same, delta T is same, so these two will not decide the heat transfer. It means heat transfer will depend only on area and length. Make sense?
हाँ.
What is area formula? Pi r square by L. So it means heat directly depend upon the radius ka square and inversely proportional to length. Now, in all the four options, you have to check length value and then you have to calculate. Make sense? हाँ प्रतिज्ञा बस खत्म होने वाला है 2 मिनट में 5 लास्ट क्वेश्चन है हाँ बस ये लास्ट क्वेश्चन ओके हाँ guys समझ में आया अनविता अनविता अंडरस्टूड
Yeah.
सो व्हाट शुड बी द आंसर
Second वाला.
एग्जैक्टली सेकंड वाला बिकॉज़ हियर यू हैव मैक्सिमम वैल्यू 4 in first it is 1 in third 1 by 2 in fourth 2 yes or no Barinder Chandana Pratigya any doubt
No, sir.
No, sir.
okay so directly depend upon area so R square inversely depend upon L all four options are given you have to put the values and see the option if this is R by 1 1 by 1 this is R square 2 to the 4 by 1 third R is 1 length is 2 and here 4 by 2 and all the question of heat transfer just imagine 28 16 16 to 28 13 question are there only from this topic total 28 13 only from heat transfer you can imagine the significance of this topic. Okay. So finish this PDF I'm sending you in the group as well. And we are officially done with the thermal property of matter and thermodynamic. We did thermodynamic question as well in class. Okay. And I will send this PDF as well, where you have all the short notes. Anything else we are left with from this chapter? But remember, until unless you don't solve 100 question, 60 question from thermodynamic, 40 question at least from this chapter, you won't be confident. Okay, that's all for this class. Any doubt?
No, sir.